Hello all. In the series of covering SAT topics, this is our 21st video where we will discuss about triangle trigonometry. Suppose there is a right angle triangle, then first we need to identify opposite, adjacent and hypotenuse in this. So how we can do that? See, suppose this is the right triangle to us, then you can see this is the right angle. Apart from this angle, we are having two more angles. One is this one is this one. So suppose this one is theta. So about which angle we need to find any trigonometric ratio, we will consider that as the target angle. And now according to that angle only trigonometric ratios are defined. Suppose here we need to write sine theta. Then that is given by opposite over adjacent. But which one is opposite? The side facing this angle theta is opposite. That means this will be the opposite. If you will see this one, always the side facing the right angle is hypotenuse. It does not matter where this target angle is there. Then this is adjacent. So sine theta is given by opposite over hypotenuse. Cos theta is given by adjacent over hypotenuse. Next is tan theta, which is basically sine theta over cos theta. That means ratio of sine theta and cos theta, which is given by, that means if you will divide these two, you will be getting opposite over adjacent. Now there can be questions like, see, suppose the question is given as this is a right angle triangle, and in this triangle suppose this is angle theta, this is the right angle, and this is given to us like this one is given as 20, this is given as 29, and we need to find sine theta, cos theta and tan theta. Then you can see opposite and hypotenuse is given to us, but we don't know what is the adjacent. But for cos theta and tan theta we need the adjacent. So what we will do, we will first find this adjacent, and since it is a right angle triangle, so we can use here Pythagorean theorem. Suppose this side is x, then using the Pythagorean theorem, what we can write? We can write x square plus 20 square is equal to 29 square. That means from here we will be getting x square is equal to 841 minus 400. So 841 minus 400, which we will be getting as square root of 441, which is equal to 21. That means x we are getting 21, which is adjacent. Now sine theta will be equal to opposite over hypotenuse, that means 20 over 29. Then cos theta will be equal to adjacent over hypotenuse, that means 21 over 29, and tan theta will be opposite over adjacent, that means 20 over 21. So this is how we can find the values of sine theta, cos theta and tan theta. And apart from these, three more trigonometric ratios are there, which is not in SAT syllabus, but we can know them. Like sine theta is there, we are having cosecant theta, which is written as CSC theta, which is basically reciprocal of sine theta. Similarly, we are having reciprocal of cos theta, which is given as secant theta, that is sec theta, which is equal to 1 over cos theta. And similar to that, we have reciprocal of tan theta, which is known as cot theta. So that is equal to, the cot means cotangent. So here it's 1 over tangent, that is tan theta. Now moving on to next topic. So in this one, calculator is required very much. Like suppose it is given. Now next topic we have to do is finding the missing side. So what we can do, suppose it's given that there is a triangle where this angle is given, suppose 30 degree, and this one is given as 5, and suppose this is x and this is y, which we need to find. So what we can do here, as you can see, this is 30 degree, opposite is 5, adjacent is x and hypotenuse is y. So with opposite and hypotenuse we can use sine. So we can write sine 30 degree is equal to 5 over y. So using calculator we will have to find the value of sine 30 degree, which you will be getting as 1 over 2, that is 0.5. So that is equal to 5 over y. On cross multiplication we will be getting y is equal to 5 times 2, that is equal to 10. That means hypotenuse we have got 10. Now the third one we can use, either we can use Pythagorean theorem or we can use the trigonometric ratio also. So either we can use 10 or we can also use cosine, because we have found hypotenuse now. So let's use 10. So tan 30 degree will be equal to 5 over x, and tan 30 degree value when you will check in the calculator, that will come out to be 1 over root 3 in the radical form, and that is equal to 5 over x. So from here on cross multiplication we will be getting x equal to 5 root 3 in the radical form. You can convert this into decimal form also using calculator. So x is 5 root 3 and y is 10. So these are the values. This is how we find the missing sides. Either first of all one of them we need to find using trigonometric ratio, the other one we can find using trigonometric ratio or Pythagorean theorem, any of these two. Now next we have to do is finding the missing angle. So for this what we have to know is this is related to inverse trigonometry. So just like above we did, suppose there is a right angle triangle where this is theta and this is opposite, hypotenuse and adjacent. Then just like we have written normal trigonometric ratio, here we will be having inverse trigonometric ratio. So we know that sine theta is equal to opposite over hypotenuse. So if we take the inverse, then this can be written as theta is equal to sine inverse opposite over hypotenuse. And similar to this, we can write the formula for other two also. That is theta is equal to cos inverse adjacent over hypotenuse. Then theta is equal to tan inverse opposite over adjacent. So these are the three formula we can use finding the angles where trigonometric ratios are used but inverse of them. For example, let's take a question. Suppose the question we are having is, suppose here it's given as just theta, this is given as 3, this is given as 5. Then you can see here, if these two are given and this one is theta and we need to find the value of theta, then we can write sine theta is equal to opposite over adjacent. That means theta is equal to sine inverse 3 over 5. And for this now you have to use the calculator. So when you will do this on calculator, it will come close to 37 degree. So this is how we are finding the missing angles. Now let's move to unit circle. So for unit circle, you have to remember that remember an identity of sine and cos. Sine square theta plus cos square theta is always equal to 1. And if you remember the equation of circle, then if the equation of circle having a center at origin, then that can be written as x square plus y square equal to r square. And if radius is 1, then that can be written as this. So this one is unit circle. If we put x equal to one of them and y equal to one of them, then you will be getting this one. So what we get, x we put equal to cos theta and y coordinate is given by sine theta. So let's start. Since x coordinate is cos theta and y coordinate is sine theta, we will draw a unit circle. Suppose this is the coordinate axis and this is a circle on the coordinate axis, and suppose some angles we have to draw here. This is y axis, this is x axis. So for some of the angles we should know the trigonometric ratios and we will be doing that thing. So first 30 degree. Suppose this is 30 degree, then here we can write cos 30 degree, sine 30 degree, which if you will see in the calculator, it will give you cos 30 degree is root 3 over 2, whereas sine 30 degree is 1 over 2. That means here x coordinate will be 1 over 2, whereas y coordinate will be y coordinate will be 1 over 2 and x coordinate will be root 3 over 2. Then we are having 45 degree. This is cos 45 degree, sine 45 degree. So that we will be getting root 2 over 2 comma root 2 over 2. Then 60 degree. So here we will be writing cos 60 degree and sine 60 degree. So it will be, see, this one will be the image of, these two are image of each other about the line y equal to x. That means about this line. So here we will be getting just opposite. That means 1 over 2 and root 3 over 2. Now from here on everything will be opposite. This one was cos 0 sine 0. So that is 1 comma 0. And this at this position it will be 0 comma 1. And similar to that we will be getting here 120 degree, 135 degree, and 150 degree. So here the image of this about y-axis. So we'll be getting x coordinate as -1/2, y coordinate as √3/2. Then here we'll be getting x coordinate as -√2/2, y coordinate as √2/2. Then x coordinate will be getting -√3/2, and y coordinate will be getting 1/2. Moving here, this is 210 degree, 225 degree, and suppose 240 degree. So here we will be getting image of this about x-axis. So both will become negative. So -√3/2 and 1/2. Here we will be getting image of this, that means -√2/2 and √2/2. And here we can write, here we will be getting opposite of this one, that means -1/2 and √3/2, -√3/2, and here also negative. Then here again these three we will be getting. So then here the three angles we will be having is this one will be 300 degree, then 315 degree, and 330 degree. So this one will be the image of cos 60 sin 60 about x-axis. So we'll be getting 1/2 and -√3/2. Here we will be getting √2/2, -√2/2. Here we will be getting √3/2 and -1/2. So from here one thing would have been clear, that where in which quadrant sine will be positive, in which quadrant cos will be positive. So you can see in the first quadrant and second quadrant sine is positive. In third quadrant both are negative, and in fourth quadrant cosine is positive and sine is negative. So if in third quadrant both are negative, then in third quadrant we will be getting 10 as positive, because 10 was the ratio of sine and cosine. So we can write here, suppose this is first quadrant, that is 0 to 90 degree. This is second quadrant, which is 90 degree to 180 degree. This is third quadrant, which is 180 degree to 270 degree. This is fourth quadrant, which is 270 degree to 360 degree. So in the first quadrant all trigonometric ratios, all 6 I mean, the previous 3 was sine, cosine and tan, and then cosec, sec and cot, all positive. In second quadrant sine is positive, that means it's reciprocal, that is cosec will also be positive. In third quadrant tan is positive, that means cot is its reciprocal, which is also positive. In the fourth quadrant cos is positive, that means sec will also be positive. So this is what we will be getting. Now how we can find the trigonometric ratios for bigger angles, like we have seen in the unit circle method, but that will be a little too lengthy. So we have to remember one thing, that is whenever any trigonometric ratio is written, before this let's know about how to convert these from degree to radian. Then we will be discussing this one. So what we will be getting here, conversion from degree to radian. So for this we need to just remember a result, that is 180 degree is equal to pi radian, and we will be using this result to convert degree to radian, or even radian to degree. So what we will be doing here, suppose since 180 degree is pi, so we have to know the formula which I was saying, that any trig, and that is the trig, and any angle is there, any trigonometric ratio, any angle is there, which can be written as multiple of pi or 180 degree. That means we can say n pi or 180 degree, that means n times of 180 degree, plus or minus theta. That can be simply written as trig theta with a positive or negative sign, but this positive and negative sign will depend on where this angle is lying, where this angle will be lying. Now what we have to know about this is, we can do a question on this. So suppose the question given to us is, we have to find sine 150 degree. Next we have to find cos. We can take any value like cos. Suppose here we will be getting sine 150 degree, which can be written in the above form, as we have sine 150 degree can be written as sine 180 degree minus 30 degree, which is in the above form, which is equal to sine 30 degree, because trig of n pi or 180 degree plus or minus theta is trig theta, but with a positive or negative sign. And since 150 degree is lying in the second quadrant, that means it will be positive only. So the value we will be getting is 1 over 2, which we had discussed earlier. Then cos 240 degree. For cos 240 degree, we can write this as cos 180 degree plus 60 degree. That means this can be simply written as cos 60 degree with a positive or negative sign depending on the quadrant. And 240 degree is lying in the third quadrant. And in third quadrant, cosine is negative. So we'll put a negative sign here. And cos 60 degree is again 1 over 2. So we'll be getting negative 1 over 2 here. Tan 300 degree, that can be written as tan 360 degree minus 60 degree, and that will be equal to just tan 60 degree with a positive or negative sign. So how will be getting that positive or negative sign? We can get the positive or negative sign with where it is lying. So it is lying in the fourth quadrant, and in fourth quadrant tangent is negative. Only cos and sec are positive in fourth quadrant. So we can give here negative sign. So we'll be getting tan 60 degree is root 3. So we'll be getting negative root 3. So that is how we will be doing these types of questions in triangle trigonometry. And that's all about this topic. We will meet again in the next video with questions.